Welcome back to another HVAC-Engineering-Techie training video. Today's video is on electrical safety. Now, electrical safety is important for every kind of technician, whether you're an electrician, whether you're a test and balance guy, whether you're a commissioning person, whether you're a mechanical HVAC technician, controls technician. Electrical safety is paramount for you to be safe on the site. So this is a very important video. Thank you very much for watching the videos. Appreciate you being a subscribing member. If you're not, I'd really appreciate you become one. Just hit the subscribe button. Give me a thumbs up if you like the videos. That stuff keeps me on the air. It doesn't cost you anything. It's absolutely free. No one will ever bug you. I'd really appreciate it if you do that. So let's get started on electrical safety. So the first thing we're going to look at for safety training is what videos we have in the electrical system training sessions. So D10 is electrical system design for non-electrical engineers. It's design light, electrical lighting design light again. Electrical motors and drive systems, and S12 is a system course. S50 is basic electrical for commissioners or technicians. 51 electrical power distribution systems. S52 critical power distribution systems. S53 electrical lighting systems. S-54, which is this video, is on electrical safety, and this applies to everyone. CX9 is Technical CX of Electrical Systems Part 1. CX10 is Technical CX of Electrical Systems Part 2. Part 1 is for pre-functional test and everything done before those. And CX10 is everything after PFDs, which includes functional tests. So this is the one that is the basic commissioning part and works on the installation. This one actually works on the actual testing to make sure that the systems actually work. This is the hardest one. This is the one we're trying to get through to people that these are the things we need to do. So electrical system safety, our safety standards in America are from OSHA. It's the Occupational Safety and Health Administration. You have safety rules. They publish safety rules. They also do site inspections to make sure they're followed. And if they're not followed, the contractors can get fined. So most contractors do this because they don't want their people hurt. They need the people. So the rules for electrical safety is never work alone. Always be aware of the power path. Use lockout, tagout locks so someone can't inadvertently turn your circuit on. Always test for power. Never assume it's off. Wear protective gear. Use insulated tools. Ladder and lift is safety issues. Extension cord safety. Safety responsibility. So electrical safety, never work alone. Electrical shock can immobilize and can stop heart and lung function. So you need to have someone else there that can administer aid in case you get tied up with a piece of gear or something. Always have a way to remove a partner from an electrical shock. A hook, insulated gloves, boots, mats, whatever. Always have a safety plan. Know what to do if someone gets shocked. Be prepared for CPR. Be prepared for emergency evacuation. Always be aware of the power path. Safe distance from power and ground path. Minimum mark distances. Respect all safety barriers. It's very important that you do this because this can actually kill you if you're not careful. So here is the data that's from, this is working clearances are from NFPA 70E. And the utility approaches from the Utility Council data. So these are the different data. So if this is the voltages over here, this is the working clearance between power and inert media. This is working clearance between power and ground. This is working clearance between power and power. So if you have 120 volts, it means there's no clearance. Just don't let them touch. Don't touch it. Don't let it touch anything else that's grounded. 460 volts, so anything between 120 is the same. No contact. You don't have to have an inch clearance, but just don't let it touch. 600 volt, now the clearances jump to 3 inch, 4 inch, and 5 inch at 600 volt. At 2400 volt, you can see it's still the same. At 4160, it goes up to 4 inches, 5 inches, 6 inches. So between power and ground, you got to have at least 5 inches, 6 inches at 12,040. And if you go up to 46,000 volts, you can see it's 6 and 8 and 10 inches. Now, this utility approach data is what utility says you should not be closer to the power feed than this. And this is for the power coming into the site. So 3 feet for 2400 volt. Utility distance aren't applied at these 600 volts because these are building voltages. But 3 feet down to 15,000 volt is 4 foot. 115,000 is 7 foot. 340,000 feet is 14 feet. Now what they're trying to tell you is there's arc distances. If you get a grounded source too close to a power feed, it will arc to it. And if you've never seen a power company flip a breaker on a line, you'll understand what I'm saying, because when they open the breaker, the arc follows it. The arc may be 2 or 3 feet long when it arcs across that breaker. So these distances are really, really important. And there's also corona effect over here. So I don't know if you've ever seen corona effect, but it's like a little dark spot in the air. It's not well defined, just like a smudge. That's actually the corona, this is where arcs would happen if you put a ground in there. So there are cameras, special cameras that can view a corona. So this is why we need to be real careful about how close we get to here. And I don't know, but if you've ever worked on a 12,000 volt or 15,000 volt, but when you hit a panel that's activated with 12,000 volts, the hairs will stand up on your arms. And you get a clue right away, I want to get closer to that. I'm close enough. So you want to be careful with that. Use lockout tags and locks. So turn off power before operating power cabinets. Use lockout and tag out procedures. Make sure you are the only one with a key to your lock. Can't be multiple keys. You've got to be the only one. Never remove another technician's locks. That's a no-no. Test power for all circuits that are supposed to be off. There may be more than one power source, and if you're at the breaker, you won't know that. You can only know that if you go to the machine. So always assume that the power, you need to test it. Don't assume it's off. You need to actually test it. And these are the kind of locks I'm talking about, where they have locks that go in to a panel or to a breaker, and you can have more than one lock because there can be more than one person that can have a circuit locked out. So it just means if you got your key off of it, it's still locked, then someone else has to open it. And of course, there's these cards and placards that actually say, I'm so-and-so, here's my phone number, and I've got it locked out. If you need it, you need to call me. We need to talk about it. Always test for power. Never assume it's off. Always check in case there exists a second power path. Now, it can be a second power path, but it can also be a ground feed or a short feed. So it could be another circuit that happens to be exposed to your circuit, and its problem can shard onto yours. So you need to be careful. Always check. It's a thing you must do, unless you like us guys work with 120 or 24 volt. It's not a big deal. For 24 volt, it ain't gonna hurt you that bad. But 480 volt, it will absolutely get you. So you got to be really careful about that. And then we use tools. This is a ticker, where basically you get it close to power and it starts lighting up. It tells you there's actually light power. But don't determine. I wouldn't rely on this solely. If I'm an electrician in the field, I want to take a meter and put it on there to test. There's absolutely no power. Now, just so you know, sometimes when you plug an auto meter in there, it'll show you've got millivolts on the circuit, or you might have even 1 or 2 volts. And that's somewhat common to bleed by in our modern day world. It uses a lot of triacs and a lot of transistors. They can actually leak to the ground side or leak to the common side. So there's can be a few little trickle of voltage. That's not uncommon. Doesn't mean the circuit's active. It just means that somewhere there's a diode feeding back. Protective gear. This is important. Shock, electrocution, arc flash, and arc blast. Now, I know as test and balance guys, we always complain because we don't wear the stuff we're supposed to normally. I mean, normally we're cutting into a 208 box. We're not dressed up for 208. We're dressed up for 120, which is main standard stuff. No PPE, except for maybe safety glasses and gloves. Other than that, we won't be decked out. But that's a problem because we enter them all day long. Face protection, safety glasses, hearing protection, gloves and liners, jackets, pants, and NFPA 70 levels of protection, and we'll go through what those are. Category 0 is acceptable for incidents of 0 to 0.2 kilocalories per centimeter squared. Category 1 for incidents of 2 to 4 kilocalories calories per centimeter. Category 2 is an incident of 4 to 8 calories per centimeter. 4 acceptable for instance of 8 to 25 calories per centimeter. Category 4 is 25 to 45 calories per centimeter. These are the 0 through 4. There's a 0, but basically the 0 is nothing. So there's basically 4 categories of required PPE. And here's what they look like. So we have electrical gloves. Electrical gloves can be an inner liner. That's optional, actually, but if you working in a real cold climate or something and you need some gloves that actually insulate, then you put a liner on, and then you put rubber gloves, and the rubber gloves is the protective part for the power. The liner is for comfort, and then leather gloves on the outside is to keep from damaging the rubber gloves. So that's where there's a couple other requirements. One is shield length, the cuff. There has to be a certain protection cuff length, so the Class 4 is a much bigger glove than a Class 0 glove. Class 0 just barely exits the glove, and you can see that the next one up, Class 1 is a little longer, Class 3 is a little longer, and Class 4 is the longest. And that's to keep you from being able to brush against something that might have power on it. So it's a protective deal. And then here's the color codes for the rubber gloves. So 0 is this tan. 0 is red. 0 is this kind of tan. 1 is white. 2 is yellow. 3 is green. And 4 is this oranges or red oranges. And so this is 4. You see, green is 3, yellow is 2, 1 is white. And the color of gloves matters, so because they can tell right away what power requirement we're in. Now, you have to test gloves every once in a while, and the code says every 6 months. You have to test them. You normally test them with air. You pump them up to make sure there's no pinhole leaks. A pinhole leak will actually allow an arc to enter into the glove. So we don't want that. So gloves are tested, and normally any utility or any electrical company will keep the gloves tested company-wide on a whole basis. And then anything that's failed to test is replaced. They can't be repaired. They're replaced. So it's really critical. What they don't want you to do is they don't want you trusting a rubber glove that's no good, because that's the same as not having one. So you need to have them this way. So air testing for leaks, for hole leaks. They also test them electrically. They use arcs to test them, and the impedance coming through from the possibility of the electrical current is different. But that has to be done in a factory. That's something we don't do in the field. We only use air in the field. So here's the protective gear. This is that 0, and it's just face protection, basically. It's regular cotton clothes for construction, low flammability materials, standard things. Eye protection is what's required for this. Class 1 and 2 is 8 to 11 kilocal, and you can see that it has gloves, it has face shields, it has hoods, and it has the gloves required. And the 3 is a full suit. This one doesn't have pants, but this one has a full suit. It's much larger. It's much more. It's darkened faceplates. It's much more difficult to get around in a 3 than it is a 1. And the other thing too is in my area, we're in a very hot climate. These can get insufferable when it's hot, so you can't have a person gowned up for very long. 10, 15, 20 minutes is maximum. Then he's got to come out. Someone else go back in. But he needs rest time, cool down time in between. And 4 is a much heavier unit than this one. The same thing, full coverage, full pants, full coat, full gloves, full headgear, everything, except it's a lot heavier. So this one is even worse for the heat if you have to have that. And you need to keep these on the trucks so that when a person has to enter the cabinet, they have the gear available. Electrical safety gear, hearing protection. This is probably the best kind. They do have the earplugs. In some cases, this is a much better one. Gives you much better protection than the earplugs. Face mask. This is for if you're in an area that's got particulate or gases coming off. You don't need it for the electrical part unless there's an arc flash, and it would be really nice to have one to keep from getting the contamination from the explosion into your lungs. Rubber mats, and the rubber mats are designed to put down before you work on a gear to isolate you from the ground. Man hooks are designed for your partner to have in case you get hooked up. He can jerk you off, because what happens when you get hooked up to electrical arc or to electrical short, it won't let you loose. You can't get loose because it's control of your nervous system. You no longer have control of that. So that's what the hook is for your partner to grab you and jerk you away from that. It uses insulated tools. They have screwdrivers. You can see they're insulated clear down to the shaft. Nut drivers that are insulated the same. Wrenches that are all insulated. Even crescent wrenches that are insulated. Torque wrenches that are insulated. Pliers that are insulated. And then we have wrench sets that have entire sets of them insulated. What this is intended to do is so you don't just happen, if you're on a bolted connection, you don't actually touch the other connection because you're insulated from it. So that's very important to use these. Ladder safety, which is another safety issue. Choose the right ladder. Different types of ladders are designed for a specific task. Ensure that the ladder you select has the appropriate load rating for your weight and any tools or materials you will be using. For electrical work, all ladders should be fiberglass ladders and not aluminum ladders. They should be non-conductive. So in case you drop a live cable on it, it's not going to light up. Inspect before use. Always check your ladder for any signs of damage before using it. Look for structural issues such as bent side rails, loose rungs, or any other defects that could compromise safety. If you find any damage, do not use the ladder. The ladder needs to be discarded. Wear protective footwear. Use slip-resistant shoes to maintain grip while climbing. Avoid shoes with leather soles, as they can be slippery if they get wet. So this means your safety shoes should be a shoe that has a rubber sole. Limit usage. Only one person should be on a ladder at a time, unless it is specifically designed for multiple users. I haven't seen many of those. They are available, but I haven't seen them. This helps prevent overloading and reduces the risk of accidents. Okay, extension ladders. We have these different kinds. Extension ladders. Ensure the ladder is on a firm, level surface and both feet are in contact with the ground. It's really important that it has feet with the rubber pads and they're both where they should be on the ground. Where the ground is firm but uneven, use a ladder with extension feet. So make these ladders with extension feet so you're going to be on level ground. Always face the ladder when you're ascending and descending. Never come down the ladder backwards. Ensure that 3 limbs are in contact with the ladder at all times. In other words, you can't be leaning way out where only your 2 feet are on the ladder. That doesn't work. Or you can't be hanging 1 foot and 1 hand and hanging out to get something. You need to move the ladder. Always position the ladder at the correct angle. For every 4 feet of unsupported ladder length, the base of the ladder should be 1 foot from the vertical wall. And that's the maximum tilt angle of the ladder. The ladder must be extended 3 feet or 3 rungs past the top of the structure. And that's for safety for getting on and off the ladder. The ladder should be secured against slipping at both the top and the base of the ladder. So that means once the ladder's up, you should tie it off to the structure or something so that it can't be moved. And that's true of the bottom, but especially true of the top. Because a tall ladder, if you're on a 36-foot ladder or 40-foot ladder, it's a problem. So you need to have that ladder tied down. Pole straps must be used against structures such as trees and poles. If you're on a pole, you have to have a strap on it so that it can't move over the round part of the pole. Do not climb from one ladder to another. You need to go down and back up another ladder. Do not use an extension ladder in a horizontal position as a bridge structure or as a scaffold. They are not designed for that. Their structural is always in a different plane, so you cannot do that. Do not exceed the load rating of the ladder, please. If you're 400 pounds, you're not climbing up any of these ladders. They're normally rated for 250, 275 pounds. Some are rated at 300 pounds, but not much more than that. So step ladders. Always ensure that the ladder is placed on a firm, level surface, that all 4 feet are on level ground. Check that each foot is in the correct contact with the surface, that one's not lifted off. Ensure that spreaders are fully extended prior to use. These spreaders are fully down. When ascending or descending the ladder, you must be facing the ladder and have 3 limbs in contact, just like an extension ladder. Never stand or sit on the top cap of the ladder. So you can't sit on it, and you can't stand on this anything above this one. This is as high as you should stand. So you need to have the right size ladder. Do not overreach when using a ladder. Ensure your body is centered within the ladder stiles. So if you get too far out of this, if you get too far off the sides, the ladder can tip over. Always ascend the ladder prior to moving the ladder. Do not attempt to make the ladder walk. You see some wise guys trying to do that. They will do it, but it's very dangerous. Before moving a ladder, take care to ensure that all tools and other frames have been removed. Can't tell you how many times I've dropped a hammer on my head because I left it, instead of putting it in the hole, I left it loose on the ladder. Don't do that. Do not climb from one ladder to another. Do not exceed the load rating of the ladder. Carry tools and materials in a tool belt or have them passed to you. All right, platform ladders. It's like an A-frame ladder, except it's a platform ladder. It has a platform that's designed for you to stand on. Verify that the ladder has a platform at the correct height. So this height is not adjustable. So you have to have if you need a different height, you need a different ladder. Always ensure that the ladder is placed on a firm and level surface. Check that each foot is on the pattern, just like an A-frame ladder. Ensure that the platform is fully engaged before climbing the ladder. When ascending or descending the ladder, you must be facing the ladder and have 3 limbs in contact with the ladder at all times. Do not overreach when using a ladder. Ensure that the body is centered within the stiles. Always descend the ladder prior to removing the ladder. Do not attempt to make the ladder walk. Before moving the ladder, take care to ensure that all tools and other items have been removed. Do not climb from one ladder to another ladder. Okay, what about lifts, safety lifts? Attend operator training before operating the lift. So if you're not certified on this lift, don't do it. Go get some training and then be safe to do it. It's not a time to learn when you're in the air. Do not exceed the lift capacity. They're all rated capacity, and that means the capacity of the person or people that are going to be up here and the equipment or material you're going to have with you. Do not use the lift as a crane. Do not carry objects larger than the lift platform. Do not drive with the lift raised. In other words, don't try to go motoring around with you on top of it raised. Do not operate the unit from the lower controls. In other words, the units have controls up here for the operator and they have controls down here. Well, these down here are designed for when you're off the unit and you're moving the unit, not when you're on it. So if someone's up here working, don't move it from down below controls. Do not exceed the vertical or horizontal limits, which is obvious. Do not operate the lift in high winds, because wind could possibly blow the unit over. Do not override any hydraulic, mechanical, or electrical safety devices. They're there for a purpose. Assume all electrical wires are live. Stay at least 10 feet away from all power lines. Be aware of overhead clearance and objects. Always set outriggers on pads or level surfaces. If you're driving one of these, the outriggers need to be set correctly. Use wheel locks on sloped surfaces. On a sloped surface, you want to make sure you have wheel locks. Set up work zone areas like cones or safety tape. So to make sure your work areas, other people are safe in what you're doing. They should not be able to walk under your lift while you're doing this. So fall safety, another safety issue. Never work in an area where you feel unsafe, including areas without proper guard railings. Use safety harnesses when working near the edge of a building or above required heights. So these harnesses, you wear these and they'll be tied off to a tied-off point that's certified to be a life safety tie-off point. And then this is a static lifeline. These are ones that extend out and back, so they're automatic, and you can move around with this one. And they're designed. This maximum length is still less than the fall requirement, but it lets you move. With this one, you have to reattach every time you move. Safety harness and anchor points must meet OSHA safety standards. Extension cord safety. Inspect the extension cords daily to verify there are no damage to the cord and that connections are in a proper working order. Very important. Do not overload extension cords or allow them to run through water or snow on the ground. Don't want to tempt your fate. Do not use an extension cord for more than one tool or device. And that's the reason, because they want to make sure you're within the load limit of the cable. Use only extension cords that have equal or greater amp ratings for the cord length. Use only extension cords that have equal or greater amp ratings for the cord length than the amp draw of the tool or device you are using. Never use a tool that feels hot or is damaged in any way. Touching even a single exposed strand could give you an electric shock or burn. Use only extension cords with polarized and or 3-prong plugs. Buy only cords approved by an independent testing laboratory such as Underwater's Laboratory, Intertech, or Canadian Standards Associations. So extension cord designation, they come in different designations in case you need a special one for what the job you're working on. S is designed for general use. W rated for outdoor use. J standard 300 volt insulation. T made with vinyl thermoplastic. Normally we have 600 volt, by the way. Parallel wire cords. Oil resistance. E made from TPE. Cord length and amperage lengths. So a 25 to 50 foot cord, a 16 gauge will carry 13 amps, a 14 gauge 15 amps, a 12 gauge 16 to 20 amps. I'm not sure about a 10 gauge. 100 foot length, 16 gauge is 10 amps, 14 gauge is 13 amps, 12 gauge is 15 amps, 10 gauge is 20 amps, 12 gauge is 15 amps, is 20 amps. 150 feet cords, 14 is 7 amps, 12 is 8, 10 amps, 10 is 15 amps. So now what we're talking about here is if you have a 100-foot cord and you want to put two of them together, and you can make a 200-foot cord, this 12 gauge is no longer 15 amps, it's 7 amps if it's 200 feet long. So you need to remember that the amperage goes down with the length of the extension cord. Do not string extension cords together unless the wire size has the correct amp rating at the extended total length. So that's why we try to use one cord most of the time, not two. And we never plug more than one device in just in case you're at 7 amps and someone else plugged into your cord. Now all of a sudden you're 10 or 12 amps and it's a 14 gauge wire, ain't going to work. So that's why we only use one device per cord. Safety responsibility. If you are an engineer, technician, inspector, or commissioner, you need to assess any electrical devices or energize an electrical cabinet. Always arrange for the electrical contractor to be present. Remember, the electrical contractor has total responsibility for the electrical system. Its operation is warranty. What I always stress to a commissioner is this is not your gear. It's not your system. You don't own it. So you always need to have the owner there to take charge of it. Now, you can actually enter a panel if they say it's okay and you're there with you, then you could do that. My advice is always have if you're in construction, have the electrician open the panel. And if you have a complicated reading, let him take the reading for you. It's just the way things should be. Always depend upon the electrical contractor person to open, read, and close energized electrical panels. Never assume the safety responsibility of the electrical contractor. Now, if you're on an existing facility, then you need to meet the owner's protocols for entering a cabinet. Never assume safety is somebody else's responsibility. Safety is everyone's responsibility. We don't want to have to leave a job because we've been hurt or damaged. So be safe. It's really important. So I hope that video was meaningful to you. There's a lot of different training videos and everything for safety. OSHA has an 8-hour course and a 40-hour course. They're very, very good, but they're very, very boring. So you gotta, if you take the 40-hour course, be prepared to learn a lot and go through a lot, but it can be very dry and very boring, but very essential. So everyone should go through at least the 8-hour course, which is all the things I've just explained to you, but maybe a little bit more detail. So I hope you guys have a great day. I really appreciate you watching the videos. If you have any questions, put them down in the comments and I will get to them eventually. Thanks a lot. Have a great day, and I'll catch you on the next one.